Thank you, Ian and Ulrich, for the presentation. I'd like to welcome you all to this session on managing e-commerce growth, which comprises of 3 presentations followed by a question and answers session. Topics covered in the session range from customs automation, autonomous mobile robotics, and split tilt tray sorter design. As Ian said in his introduction earlier, we're using the Slido app, which is on the right-hand side of your video screen, for you to post any questions. And we will address all of those questions when all of the 3 presentations have been completed. So our first presentation on automating inbound operations will be given by Paulo Silva, Head of R&D, Production and Logistics, and Pedro Nabe, Department Head, Engineering and Technology with CTT Portugal. I'll now hand over to Paulo and Pedro.
Hello to all. I'm Paulo Silva, Operation Planning and Development Director at CTT Operation, and I'm very pleased to be once more in ICPA and have the opportunity to share experience and discuss breakthrough projects in our industry. I will be presenting with Pedro Navais, who will soon follow me, and today I want to share with you the innovative solution and set of best practices we had to come up with to answer one of the most transformative disruptions of recent years in the postal industry, namely the European Union cross-border new regulation. As if that were not enough, we had to build and deploy our transformation program during a pandemic. We want to briefly present to you how we are hoping to automate our process across all the postal network, moving from an almost entirely manual activity to a seamless workflow, and delivering automation to simplify customers' process and client interactions. This is a problem that all European Union postal operators are facing, the end of VAT exception for low-value goods below 22 euros that right now don't have any restriction entering the European Union zone. As of today, almost all the cross-border e-commerce received by CTT don't pay duty fees or taxes. In 2019, last year before COVID, less than 2% of 20 million packets received from outside the European Union were considered declarable and were chosen to formalize the custom declaration with an unproductive process for data collection, multiply client interaction to fill missing data, time-consuming validation with the customs authorities, payment, and so on. However, from July onwards, this situation will change drastically. All cross-border packets must pay VAT and customs duties. And new solution will have to be found to enable the collection and massive submission of millions of individual customer declarations. Pedro will now show you how we are addressing this challenge.
Okay, thank you, Paulo. So my name is Pedro Navais, close enough chain. And I'm responsible for engineering and innovation at operations at CTT, both in mail and parcels. So it's like Paulo said, it's a pleasure for us to be once more here at the ICPA. And so I would like to start with what comes to my mind whenever I think of the customs process. And it's one of my childhood heroes, Asterix. So when I think of customs and what is going to my mind is one of their movies where he has to go from in a bureaucratic building from floor to floor, from clerk to clerk, trying to find the correct form so he can finally leave the building. The task is called the madhouse. So that's what's going on in my mind whenever I think of the customs. So and he has to find this permit 38 to finally set him free. And our current process is nearly as daunting. So like Paulo said, so it's almost entirely supported on labor-intensive tasks, has confusing rules with not enough integration, has multiple unproductive interaction with both the client and the customs, and in the end is time consuming for all parties and it's impossible to scale up. So we needed to answer the challenges that we're facing. We needed to transform our operational model and we needed to change this customer journey. So we started with the new site. So we started with first step that we had to do is find the correct space. So this new site was built to host all of our cross-border and customs activities. This building has almost 14,000 square meters. It's the interaction here with Ian and the Canada Post, and this is the first step that we are making in our goal to provide a cost-effective and flexible process for answer this continuous demand of e-commerce. But there is, of course, much to do. And what was our transformation program really about? So what was the transformation program really about? So it's a program that covers 5 main areas. So we invested in automation with a new sorter that is dedicated on these small packets, on this Chinese packet mainly, and it is specialized on this OCR for the CN22 and 23 forms. We revisited our logistic model, so with new pallet boxes with wheels that are optimized for reverse logistic, and we also streamline our sorting in feed with bulk downloading that is supported by a tipper. We also created a new model for deploying the business rules, the way that we looked at the sorting business rules with a centralized server where all the rules are defined and that is shared by multiple sorters and has real-time communication with the machine. And we are deploying areas that we think that has much potential, that is creating a digital twin of all operational processes and trying to map all the entities that we have on the site for both long and short-term scenario. And finally, on this program, we wanted to seize this opportunity to upgrade all connected processes. So with this new generated data that we are going to have, with these new streamlined processes, we also want to lever this in more efficient process downstream. And starting with the sorter, so I'm going to ask for the video to be played, please. I'm training. Okay. So, thank you. So this is a test that we are doing with our new high-performance sorter. This is prepared for these small packages with around 8,000 items per hour. These features are optimized for this package below 5 kilos. And that is this business area scope. And we have a gated conveyor that will distribute efficiently this bulk flow from each one of the 6 automatic scanning positions. We also have 2 additional manual positions for hard-to-read barcodes that we use for these hard-to-read barcodes or for relabeling. And we will have 20 outfits with the ability to grow that will enable us to manage all the different workflow rules. For instance, returns, pending items, different service levels, custom retentions, outward sorting, postal codes, etc. This will be managed by an event-driven and service-based architecture. And what this means is that whenever we have an interaction with the package, both virtual or physically, there are going to be a different services, a set of services that is going to be called to handle track and trace events or contact with clients, sharing data with the customs authority, OCR to process image, etc. Okay, so and talking about the OCR, we, as I said, so we developed this. This specialized OCR. So whenever we don't have an ITMAT or any kind of manifest, so or any complete information, So what we are going to have is this dedicated OCR that is specialized in these different shapes and sizes on CN22, and will have focalized algorithms for this area, for region of interest detection, for converting image to text, for even to address database that usually is very different on this package. So with the fuzzy logic to trying to match our national address database. So, and the goal here is to fetch or to complete the information about the contact data. What being name, mail, phone, address. So the goal here is to facilitate the communication with your final client. If we don't have an OCR decision, then we are going to send the image to a web-based video coding system where the CTT operator will data entry all the data for all this contact data information. And this can be done anywhere, including, of course, their homes, which is always important in this pandemic environment. One of the main changes that we have is that, like I said, was about the way that we handle the sorting business rules. And so a new system was developed to remove all the sorting logic, including the sorting plans, from the machine. And we are going to transfer it to an external server. The idea here is that every component of the workflow should focus on what can do best and promote this fast communication between components. And here, the main concern of the machines will be sorting. Okay, so how the process is designed, all the sorting is decided to go to a different outfeed, etc. All of these logistics should be handled by CTT experts and completely independent of the machine. Okay, so in this context, the sorter, will only handle the mechanical aspects of the sorting. So and to low-level error handling, for instance, communication error, tracking losses, all the rest. So sorting decision, the redundancy of the outfeeds, no read errors, etc. All of this is handled by this central server where all the business rules are set. We are going to give you a small example of our vision to facilitate the comprehension. So what we are going to have here is, so we are going to start, of course, with this. This is a very simple process without OCR, intermediary communications. It's just for us to present to better present our view. So we are going to start with business rules configuration. So where everything that is related with that can influence the decision will be set. So we are going to decide about the custom stage validation, postal codes, the country of origin, if there are some security alerts that we need to take into account, weight, volume, if the payment was done or not. Okay, and with that in mind, we are going to define what these rules are, and then we are going to receive the manifest. We are going to receive the different kinds of message, and whenever a package is sent, and we are going to instantiate for each message that we receive, for this unique S10 code, for this unique object, we are going to decide what rules are to be applied. Of course, whenever there is an interaction, whenever there is a change in the workflow, we are going to revisit and recalculate these rules. Okay, so these rules that can be applied to that special package will be stored. Of course, that at the same time, the package is being sent to Portugal at a very slower pace, of course. But whenever whenever it reaches Portugal, we are going to sort them on our sorter, on our tax machine. We are going to read the barcode, and in real time, we are going to make a request for this decision server, where we are going to send, okay, this is the barcode that I've read, and some data collected from the machine, for instance, like weight, volume, timestamps. Okay, this is the information that I have. Please tell me what should I do with it. And this central server will analyze, will look at the rules, and will send in real time the information for the machine. So this should sort on outfeed number 3. At the same time, of course, we can share some information about the customers, some track and trace events and visibility, but this will lead to the sorting. And this can be sorting for verification. Okay, so we have to store the packet until we have a custom decision, or a return to country of origin, or eventually, if the cycle is complete, it's going to be sent to a sorter downstream. And of course, we are going to move if everything goes correctly with the delivery. Okay, and moving on and accelerating. So we also so the goal here is to have a complete flexibility and machine independence. Moving on for logistics, so for efficient reasons and to increase automation levels, we deployed these new storage units. So a large box that is aero pallet compatible, and they have wheels to facilitate the transport and to remove them from the machine and to replace it by another one. So each package is linked automatically to the destination box, so it's possible to have end-to-end traceability on the package. And those big boxes are foldable and stackable, so can reduce reverse logistic cost. That is always a concern. And like I said, the bulk line was installed that with the help of a container tipper for automatic transportation to operators' workstations. We are also moving on the digital replica. If you can please share the small video, the small final video. Okay, so this is a digital replica of all of our operations. So mapping all the entities, machine, boxes, resources, storage, manifest. And our goal here is to have a digital twin of live operations. So not using this as only for scenarios, but trying to incorporate near real-time data for using also for short-term decisions on operations, maintenance, training, and new processes. So it's like I said, there are multiple synergies that we can have with this new model. So we can share the postal decision with sorted downstreams, be it by manifest or OCR, which will reduce overall error and manual tasks like manual sorting or video coding. This process flexibility allows us to allocate the machine free time for other products. So the only thing that we need to do is to change the decision server and add the additional rules, like for instance, volumetric constraints or time delivery windows. Having the data, sharing the data earlier will improve forecast accuracy and readiness of the postal network. Namely, we can adapt the sorting plans and delivery routes much more efficiently. And we have the same OCR for CN22, but also for our REST mail sorter, which of course will enable us to share resources, both hardware and software. There is still much to do. However, we are already thinking of ways to add value to this transformation. For what, some examples are, for instance, automatic asset tracking for all logistic units, both on site and transferred to other sites with active tags and 100% visibility. Machine learning for recognition. Here, the idea is that whenever video coding feels the missing data, a deep learning engine will collect all this additional information about the image, the region of interest, the extract words, address, and compare it with the data entry of the video coder, and with that, we'll automatically train and fine-tune the OCR. And of course, the robotization. We already had a very successful project with AGVs, and we think that we can use this use case to transport pallet box autonomously from the machine to warehouse or to respective loading docks and cargo areas. And finally, what we feel that, of course, that we cannot today assess the project results, and there are, like I said, much to do until July 1st deadline. However, we are confident that we have the right foundation for success, and this transformation program will drive innovation and efficiency to deliver the better experience to all parties involved. So what we feel is that so for the seller, it will be, of course, important to reduce delivery time. This program will help them reduce delivery time, reduce also the costs in refunds, and increasing the overall satisfaction will lead to potential sales increase, of course. The benefits for our operation are clear. With process automation, we can increase the throughput and at the same time save costs and increase the control and protect our revenue assurance with full image archive and 100% traceability, and the flexibility of the business rules allow us to not be only ready for the July 1st, but for all the days that will follow. And of course, the operational synergies is an example of how the digital flow can help the physical sorting. Having all of these streamlined processes and data will help streamline the customs process, and the business rules being very easy to change. It will allow for a further cooperation, because after customs decide what are the rules, a few minutes later, we can start starting with these new rules without any extra setup. And of course, in the end, this will lead to a better service to our customers, to our clients, more focused digital interactions. They feel that they are in command of the workflow with convenience, increased convenience and transparency. And of course, all of this will lead to a reduced delivery times and a better service that will result, we hope, in a satisfied customer that is willing to continue this e-commerce cycle, continues this journey with us. Thank you for your attention.
Thank you very much, Paulo and Pedro, for that very interesting presentation, and for all European postal operators, and I can speak from An Post. It's a very, very topical subject, and we're currently struggling with designing our solutions, and we're concerned about the potential for significant storage requirements while waiting for payments, etc., etc. So I'll be one that will be following up with you. So thank you very much again for that presentation. Our next presentation is on Flexi Sort Robotics. Will be given by Michael Polera, Director of Equipment Engineering with Canada Post. I'll hand over to Michael.
Thank you, Shane. Hi, everyone. I'm Mike Polera. I'm the Director of Equipment Engineering. I'm part of a broader team at Canada Post that implements new parcel and letter mail sorting systems, as well as new automation into our network. Appreciate your time today, going over Canada Post's experience in our use of autonomous mobile robotics to implement Flex sortation system. A lot of postal and courier organizations are facing similar challenges. E-commerce volumes are growing, they fluctuate wildly, and they can change in different geographic locations across your country. All of that puts a strain on your existing processing capacity overall. Customer needs are changing, whether it's new services or products or delivery commitments. Adapting to all of that is difficult to do quickly. High labor rates are a problem, and increasing labor to address these challenges is not a winning strategy to make money in the long term. Traditional sorting technologies aren't very easy to scale or modify, and they cost a lot to relocate. On top of that, if you do have to modify them, it disrupts your current operation. And in addition to that, they cost a lot up front, and you're buying more capacity than you need up front as well. The potential solution to these challenges that Canada Post looked at was the use of sortation autonomous mobile robots, or AMRs. So AMRs aren't new. There's a number of new companies, though, in the market that use AMRs for sortation. And even some traditional companies like Thieves Intralogistics and Vonderlande have offerings now as well. They're typically equipped with a cross-belt or tilt tray as a sorting mechanism. You can induct them either directly to the AMR or onto an induction belt. They'll work on an existing open floor space, or if you prefer, they can actually work on a fixed or movable platform. Some of these technologies can actually integrate with traditional fixed conveyance systems. So they'll work with roller conveyor or belt conveyor, either on your induction side or on the run out or destination side. In order to increase capacity, you just add more induction stations, robots, and floor space. And in a similar fashion, if you want to increase the number of destinations, you add more robots and floor space, but on top of that, additional chutes as well. So why look at AMRs? Well, for us, we thought that there were quite a few benefits overall. First and foremost, they're adaptable to various footprints and configurations. You've got existing real estate spaces. This technology can fit into many different footprints overall. You can scale up the capacity and destinations, but in addition, when you have low volume periods of time, you just scale down how many robots you use and you adjust to your volume and capacity needs. They're quicker to implement overall and require lower capital cost up front. As you get more volume later on, you scale up your capacity when you get more investment, and you do get that volume instead of buying it all up front. In these types of systems, with all the robots working in unison as one system, you get additional redundancy that you don't get elsewhere. And as a result of that, you get more consistent throughput and uptime. And lastly, they're easy to relocate with low financial investment. If you've got to change buildings or change your operation in an existing building, it's easy to do so, and it doesn't cost you a lot of money to do. So when Canada Post looked at potential applications, some of the ones that we felt were best, the immediate applications, were what we call conveyor-assisted manual parcel sort operations of less than 2,000 pieces an hour. I know that's a bit of a mouthful, so what is that exactly? Well, a conveyor-assisted manual parcel sort operation can take many shapes and different layouts of conveyors pieced together, but in a typical setup, there's manual item induction to a belt conveyor. There is an item scanner and dimensioner that's used for customer visibility and revenue protection. And then on the outbound side, you've got the manual sort, which is basically operators looking at each item's address label and then walking that over to the correct sort container. And CPC uses that for extra capacity at peak period, but we also use these solutions year-round in some of our smaller facilities. And unfortunately, they're terribly inefficient and labor-intensive. If I look at the layout in the bottom left, I've got two conveyor systems there. That produces about 1,600 pieces an hour of parcel sorting capacity, but employs up to 25 people. On the right is an AMR concept, where we're using AMRs to do the same thing, essentially. You can still achieve 1,600 pieces an hour. We actually do it in less floor space. We have the same amount of sort destination, but the biggest benefit is a savings of approximately 14 people per shift, because the robots are doing the actual sortation aspect of the operation. So CPC was, needless to say, very interested in the technology, and we decided that we wanted to do a proof of concept. We went to market and we took a look at what technologies were out there, and we eventually landed on leveraging Gray Orange's Ranger Move Smart AMRs. Gray Orange already had a very well-established customer base globally, and they were able to do things like integrate with fixed conveyors if CPC decided they wanted to try that out. But also their technology with their induction station doesn't require an operator to actually place items onto the AMR directly. And so we wanted to have that, to try that out basically, as it wasn't too different than what we do today. Our pilot cell consisted of a single induction station, 3 AMRs, 10 chutes, and a charging station. We're trying to achieve a target throughput of about 400 pieces an hour, and that's equivalent to one of our operators actually unloading items out of a container onto a belt per hour. The minimum package size was 100 by 100 by 5 millimeters and 20 grams in weight. The maximum package size was 650 by 450 by 400 millimeters and up to 15 kilograms. Our pilot cell was located in our Ottawa mail processing plant, and we had access to both test mail and a lot of variety of live mail as well. And we did an assessment over a 6-week period of time with the equipment. Just taking a look at the pilot cell, in the middle you'll see a layout of what that small pilot cell looked like. On the left-hand side, highlighted in green, is a typical gray-orange induction station where an operator takes an item and actually places it onto the induction station for induction onto the AMR. It consists of a topside scanner, and it has integrated weigh scales and dimensioning, and a little graphic user interface to provide operator feedback on the side. On the right-hand side of the screen, highlighted in yellow, is a typical gray-orange Ranger Move Smart AMR. Our pilot cell consisted of 3 of these AMRs. And then up top, highlighted in purple, destination chutes that we had, 10 of them, where we tried testing with a variety of different CPC containers, monos and gaylords and packet tubs, for example. So overall, the pilot was really to assess just how well this technology fits within our operation and works with our mail. I mean, we wanted to take a look at how easy was it really to install and disassemble the equipment, what human interactions were involved, the level of safety, assess the ergonomics and the ease of use. A big part of it was to assess product handling capability. We all have a variety of different mail types, sizes, and various packaging types. So we wanted to see how well the equipment actually handles all of this. We wanted to take a look at the actual throughput versus supplier claimed. In my experience, suppliers tend to claim a lot more throughput than we can actually ever achieve. So we wanted to actually measure that and see what we could get. We also looked at technology performance, looking at sort accuracy, the amount of dropped mail, and system uptime. And last but not least, we wanted to take a look at the ease and complexity of maintenance overall. Here's some of the results that we achieved. We actually achieved a throughput of about 450 pieces an hour against a target of 400. This was actually demonstrated over a long period of time with different mail types, with all 3 AMRs in operation. In terms of sort accuracy, we were about 97%. We had some issues with our Wi-Fi router and data latency. And after correcting that, we were closer to about 100% sort accuracy overall. In terms of damaged mail, we didn't damage any. The design itself was very simplified, not a lot of catch points in all of the equipment, and that was beneficial to this positive result. In regards to drop mail, we had less than 1 in 250 pieces overall. Most of the unstable items would actually cause an error on the induction station and wouldn't induct, so the operator would have to remove those. The other items that did drop actually got inducted were ones that either over-inducted onto the AMR crossbelt and were just hanging off the edge, and when the AMR was maneuvering, they would fall off, or they were really light. The dimension and weighing accuracy was not so great. We knew going in that the integrated dimensioner and weigh scale devices were not legal for trade, and so the performance was much lower than what our current systems can do overall. In terms of uptime, we were around 90%. Unfortunately, we had a single wireless router, which was responsible for communication between the AMRs, and it would drop often. In a future application, we would definitely add redundancy to the wireless router configuration overall. Some of the qualitative results and observations that we had as well. In terms of product range and challenges, the equipment actually handled the minimum package size spectrum quite well. We did have some drop mail items at the lighter end of the spectrum, but otherwise, performance was actually pretty good. Items close to the maximum length and width unfortunately cause induction errors. So we would have the operator actually try to induct it several ways. And if that didn't work out, we would ultimately have to remove it and it wouldn't get sorted in the actual work cell. Some pillow packs and round objects as well had some difficulties. And again, the operator would have to remove those items and they wouldn't be able to be sorted in the actual cell itself. From a maintenance perspective, what we saw was that problematic AMRs are able to self-park themselves without interrupting the overall live work center. And that's a great feature because your overall work center can continue to process mail while maintenance can go and go on in parallel, essentially. You know, in a future application, we would look at adding extra AMRs to account for maintenance time and charge time overall. And that way we could maintain capacity even more. Most of the components on these systems are really similar to traditional crossbelt sorters. So it's a similar complexity and maintenance cost overall. So we felt that the maintenance from an overall perspective was actually quite good on the equipment. In terms of ease of relocation, it was very apparent that it is quite easy. I mean, we set up this overall cell in less than 2 weeks. We were able to disassemble it and crate it for shipping in less than 2 days. In regards to safety, everything that we saw on the equipment was on par with current conveyor and sorting equipment that's out there. The AMRs themselves operate in a contained area that are separated from operators, but they also have obstacle detection and avoidance if required in the unlikely event that an operator would be going into the work cell. where did we land? Overall, we did see firsthand that this type of technology is easy to change layouts and configurations. In terms of scaling capacity, we ran a variety of tests with 1 to 3 AMRs, and we could see firsthand how we could scale up and scale down capacity with the technology. The integration to fixed conveyors is something that we would probably recommend in a future application, and that would address some of the ergonomic concerns, such as belt height and loading height, as well as getting better dimensioning and scanning ability by using some type of a belt conveyor system integrated with this technology as well. That limits the overall flexibility and deployment timing to a certain extent, but it's not enough of a hindrance for us not to look at this technology. The key performance measures of throughput and accuracy were actually better with this system and setup than operator-based systems that we have today. And in terms of maintenance and redundancy, I mean, all of these robots working in unison as one system really adds a level of system redundancy that's unlike any other technology out there today. But for us, this technology is definitely a suitable alternative to those conveyor-assisted manual sort parcel operations that I had mentioned earlier. But in addition, we're actually thinking this is a strong candidate to replace traditional sorting equipment, such as lower throughput applications of less than 5,000 to 6,000 pieces an hour. So for example, this technology could replace a shoe sorter or push tray sorter and would be a suitable alternative overall for something along those lines. And in summary, Canada Post is strongly considering this technology. We're actually looking at next steps right now and hope to implement a live application within the next probably year and a half or so. That's all I had for today. I appreciate everyone's time again, and thank you very much. I'll hand it back over to Shane.
Thank you, Michael, for that excellent presentation. And I think what I've taken from it is the flexibility, the potential for labor savings, and it leaves a lot of food for thought. Combined with the presentation that Mark gave yesterday, which had got similar type automation, maybe in a different application, I think that AMR technology is certainly huge potential in the future. So thank you again for a great presentation. The final presentation on the session, split tilt tray sorter design, will be given by Alan Hayes, Senior Automation Engineer in An Post. So I'll hand over to Alan.
Thank you, Shane. I'd like to welcome you all here today just to listen to me as I try and talk you through the process that we had for designing our split tilt tray parcel sorter. As Shane said, my name is Alan Hayes. I'm the Senior Automation Engineer with An Post, but I was just a member of the team that helped with the design, installation and commissioning of the recent automation within An Post. So I'd like to name check my colleagues that helped with all of this. It wasn't just me. So in summary, a number of years ago, our engineering department, we were tasked with moving An Post away from the world of manual sortation of packets and parcel mail items into a more automated world, just to bring us into the future. This gave us a couple of opportunities. The first is to increase the capacity to meet the company growth forecasts. And then the obvious one is to reduce the cost of processing these mail items. So just the overview of where we sat in the last couple of years. In 2018, all of our parcel and packet mail streams, they were sorted manually. And this, along with other kind of inefficiencies that were embedded in those processes, it gave us an upper capacity of about 120,000 items each day. Based on the building constraints that we had within our infrastructure, we had to take a two-phase approach to introduce this automation. The first phase, we focused on sorting and taking care of the parcel of mail streams. These are the larger items. In 2019, then we finalized the commission of our first automated system, which was your standard cross-belt parcel system. I think everyone's familiar with these systems. What that gave us was a massive uplift of an additional 180 items per day to our capacity, bringing us to about 300,000 items per day at peak. We also in 2019 finalized the second phase, which handled our packet mail streams. And in 2020, we finished the commissioning and installation of this split tilt tray package system. This again gives us another uplift of 100,000 plus items per day, resulting by the end of in a 2-year period, we had stretched out to 400,000 items per day. So just a summary of the two considerations of our mail streams. We have our packet items, which go on our split tilt tray systems, 100 millimeters by 100 millimeters by 10, up to our maximum of 450 long by 350 wide by 250 high. In the previous project, our original automation systems on the cross belt, we took out the larger parcel mail streams. So as I mentioned earlier on, one of our major constraints was the building footprints and then the available space we had to introduce both our systems. So with our split tilt tray system, you can see we only had a limited 40 meter by 50 meter area to actually fit this into our processing facility in Dublin. And this played into major decisions around why we selected this split tilt tray system. One of our tasks was to get up to 12,000 items per hour, and operating in a 12 p.m. to 4 a.m. operational window, we were able to achieve that 100,000 plus items quite comfortably. So our system consists of 4 bulk mail loading induction points, 16 item in singulation induction points on 2 separate mezzanines, 230 split tilt tray carriers, 2 scan tunnels, 140 diverter assisted collection chutes, and then 2 large heads-up display screens. Our bulk mail loading inductions, we had to select 2 different types of bulk mail induction systems. Our first was a hopper conveyor system, which was aimed more at our bagged and boxed mail, and it's more of a manual operation for operators to spill into these bulk conveyors. To obviously give us better throughputs, we also had the opportunity to use automated tipper inductions for our roll cage stock and our pallet box stock. This gave us an upper limit of 300 kilograms per carrier, but it also meant we could induct a lot more, a lot quicker. On the singulation stations, as the items travel up from our bulk conveyors, they arrive to the operator inducts. Here, the operators are tasked with facing the items face up and placing them on the induction belt, and they then travel onto our split tilt tray sorter. The operator places the items on the belt, but when their hands are removed and break an array of sensors, that's when the safe operation and the induction of the items take place. The operators must log on to the access induction point screens that we've added to the system. We added these screens for 2 reasons. Only fully trained staff members can log into the system, so there was a major safety consideration for us. It also gives the operators feedback, and through the software that we've developed based on our own AIRS2 data platform, we were able to gamify the screens, so we can give the operators feedback on how many items per hour they're doing, where they are in relation to their colleagues, and just to promote efficiencies and get our numbers up. Each induct was also equipped with weighing functionality. So you've probably all seen tilt tray carriers, but ours are split tilt tray carriers. And that gives us kind of more bang for our buck in that small area. We have opposing inducts loading onto the same carrier, but it is split down the center. It means we can double up the item locations that we have for induction. They can, as I said, they can be inducted from opposing inducts. And when an item is tilted, it doesn't disturb the item on the opposite side. So as we discharge an item into a collection chute, the item on the opposing side stays in place. We have 2 scan tunnels. Each one consists of 2 cameras looking at either side of our tilt trays, and they are looking top down and just viewing from the top. Our cameras our images are then forwarded onto our Prime Vision MMS system, which then relays the results back to the machine controller, and that gives us our sort destinations and results. Our collection chutes. So another one that might be a bit different if you're used to the split the tilt tray design. Because we have items on opposing side of a carrier, inside of our chutes we have a diverter, and it's a plate on a control arm, and that directs items to the correct destination as we come to its chute that it needs to be discharged in. They're designed for the IPC boxes and our own roll cage carriers. And another consideration we had with this system is there was a number of sort plan changes throughout the day. We felt that, you know, standard just signage that was fixed and didn't change wasn't adaptable enough for us in our early phase of, you know, working out the best layout for the sort plan. But then as we go into the future, as the operations team requested sort plan changes from us. So we decided to go with e-ink displays and mount these at each sort location. So as the machine controller changes the sort plan, we constructed our own middleware to work between the machine and these e-ink displays to automatically update the signage. So this, you know, what we had to do in the past was if a sign was being moved, it had to be physically moved, and there may be a delay on getting this sign, so it could lead to confusion. Here we have a 2 to 3 minute delay on a sort plan change, and all our locations are updated. Also, if we need to edit that and change it, when the sort plan is changed on the back end, these tie in straight away. So there's not two systems to control. Each group of chutes has its own print on demand system as well. So we don't need to pre-print any labels or hold this stock anywhere else. Again, this is all tied into our space considerations. We didn't have much area to hold any consumables for the machine. So our print on demand function, basically, as we need them, the labels appear and we can put them in the carriers and send them hopefully to the correct destination. So in the center of the machine, we added our 2 large heads-up displays. These are back-to-back, and they're kind of a floor map of the construction of the machine and the various, you know, important pieces of the machine for the management system team to monitor. We've added performance, key target and performance information displayed, and everyone can see it. But as part of the training, we really worked with the management team on how to read this screen that we've tailored for them and see the cause and effect to give them real-time process control of the machine performance. So when sections go red, we have given them a step 1, step 2, step 3, and give them a clear path on how to escalate to maintain uptime. Around the safety side of things, because we were moving from the old world of manual sortation, simply by implementing the bulk tippers and automating that process, we've reduced our manual handling requirements by up to 70%. Again, I've mentioned the training program and how we tied this in with our iHUD screens at each induct that only trained personnel have access to the machine. So there is a clear process control and there's clear process activities that everyone that is on that machine knows that they have to maintain. And the walkways as well was a new departure for ourselves, and that just helped us with the operational flow and the traffic management, especially at peak. And with, again, back to this confined area that we had to work with, we limited the power pallet trucks and the manual pallet trucks, how they could operate around the confines of the machine. So again, this is with, you know, safety and the best process flow around our tight machine as possible. So the results. Though the construction was delayed for the second phase due to the pandemic, we did get the system in running, commissioned and up on time for peak 2020, which was a big relief for ourselves. The staff training and the ramp up period, because of the constraints and the loss of time on the construction phase, we really had to condense this down into only a 2-week period, where we would have liked a longer ramp up just to test the machine and to test the operational staff. We were able to achieve that in a 2-week window, and consistently in that 12 to 4 a.m. operational window, we were at our target of 100,000 plus items per day in that shift. During the opening months and even till this day, there's been acceptable levels of maintenance no more than any other machine. So we're quite happy with how it worked out, even though a lot of our FAT and SAT report, well, the SAT went fine, but the FAT, we didn't really get to see it before it landed. So joys of the pandemic. And by removing the human error, just by moving away from the manual process, we have, reduced our ambient sorts to less than 1%. The learnings. So, when we started off this process, we were assessing different types of technologies. And we did pick the cross-belt system for our first phase to handle our larger items. When we sat down and finished that one off, and we're in the design phase for these smaller items, we saw, our rollies, our uniform packets that we were really going to drive towards this machine. The cross-belt, it wouldn't have been suitable. So with our partners in Boeing, we kind of selected the split tilt tray. And it really has given us the stability to really process all the really awkward ones that were hard on the other machine. And the weighing functionality that we did add, though it's not legal for trade, it is, it's data that we can collect. We did see that when we do activate this, there is a slight delay on the induction, which brings our throughputs down. So, that's something that we have to weigh off, but it's a functionality that we have there for the future if required. The key learning, we should have built a bigger machine. If you've seen Jaws, we should have had a bigger boat. The machines were, when we planned and designed them, they were lined up to do us to 2024 and beyond. But, due to the pandemic, we really are up at capacity for both systems now. So, in hindsight, a time machine, we would have built something a bit bigger. And if you can, try and not to build a machine during a pandemic. Having to deal with quarantines and delays to machine and not being able to do our FATs, we threw up some challenges along the way. Like, some of the little ones or the main ones really that we didn't get to have a look at the conveyors on site and really put them through their paces in a factory setting. So we did have small jams here and there, but we were able to sort these out, post go live, just by making small alterations. But if I had to do it again, I wouldn't do it during the pandemic, that's for sure. And just in conclusion, so from where we started, 2018, 120,000 items today of these two mail streams. Where we're at today at 400,000 is a huge increase, but it's still, unfortunately, not enough for the pressures that we're all coming under over the last year. By increasing this capacity through automation and not simply by adding manual conveyors or old-fashioned bull rings for very simple manual sortation, we've been able to decrease the cost of processing these mail streams, which obviously is beneficial for everyone within the company. And the big one is, if we didn't have these machines in time, there's no way we would have been able to handle the increases we saw in the last year. So, we were lucky in a way that we had them. We had the foresight to put them in place. So thank you for joining me. I hope that gave you some new information, and hopefully next year we'll be able to see each other in person. Thank you.